Hi everyone, in this lecture we are going to talk about sorting algorithm that C++ already provides you. It's called as inbuilt sorting algorithm. Okay, so most languages like Python, Java, JavaScript, they come with a sorting functionality inbuilt, and we can make use of this sorting functionality, and this is available in the header file called as hash include algorithm, and the function is known as a sort. Okay, so this is a very powerful function. It has a lot of use case, because when you are solving a complex problem and sorting is a small part of the problem, you won't get enough time to write a sorting algorithm on your own. Okay, so most of the times it is recommended you use the inbuilt sort function, and for most for most types of arrays it will work, and in some cases some other sorting algorithms such as counting sort, that might be more efficient. Okay, so for example, this sorting function works in order of n log n time, which is much faster than what bubble sort, selection sort and insertion sort do. Those algorithms take order of n square time, because we say so they have a nested loop structure, and both the loops together they work in n square time. Okay, so this is an efficient algorithm. We will also discuss some n log n algorithms in this course, such as merge sort, quick sort, but for many problems you can easily make your work easy by using this sort function. So I'm going to teach you how you can use this sort function. It's pretty easy. The first thing you need to pass is the starting point of the array from where you need to sort. Okay, so I want to start from this point, so I will pass in the array. I want to sort this particular point, so I have to pass one index after this index. So this index is n minus 1, so I have to say from start till the end you have to do the sorting. So this is an open interval, that means we have to give end till this particular point. So this is n. Okay, so we have to say start from array and start till the end, array plus n, and this sort function is going to do the work for you. So this sort function is defined in this file hash include algorithm, and now if I print the output, what I will see the sorted array for int x that is there inside array. I can just see out x. Let's see the output, and let me run the code. Inbuilt sort, and you can see we are getting this nice sorted array. Okay, now some of you may ask how we can actually reverse the output. Maybe I want to change the output to a different order. So there are two options. One is we can use something known as comparators, or we can also use a function that is there. So we can say reverse the entire array, and we will get the output in the descending order, and you can see we are getting the entire output in the reversed order. If you don't want to do this, maybe you can write a comparator function. So what this method takes, it also accepts a function as a parameter. Okay, so basically we will write a boolean function, bool compare int a int b, and we can return a greater than b. Maybe let's see what is going to happen if I build this code and I pass in this compare function here. Okay, so if I now do this again, I'm able to reverse the comparison using a comparator. Okay, so now you may ask how this comparator is going to work. If I change this arrow here, I will get the output in an ascending order. Okay, and you can see now if you look carefully, this is nothing, this is not a function call. Okay, this is not a function call, because whenever we make a function call, we do it using round brackets. We say okay, make a call to this function. We are not doing a function call, but instead we are passing a function as a parameter to another function. Okay, so the inbuilt function is defined in such a manner it can accept a function as a parameter, and it is an optional parameter to another function. Okay, and this compare function basically controls how we should do the comparison. Okay, so if I show you this example with bubble sort code, let us try to make bubble sort, and if I put a compare function here, okay, and instead of doing this comparison like this here, I can say no, I will do this comparison using a compare function. Okay, so I can say compare aj and aj plus 1. Okay, and we have defined the compare function here, and if I now run bubble sort, I will see some output. Let us see. Okay, dot slash bubble sort, and you can see we are getting the elements in the reverse order. But what happens if I change this to a greater than b? Then I can see I get a output in a different order. I get the elements in a increasing order, right? So now I'm saying that this bubble sort is actually making calls to this compare function to find out in which direction we need to do the sorting. So similarly, this inbuilt sort function has some logic written. So there are some lines of code, and in one of those lines it is going to call a function which we are going to pass in as a parameter. Okay, so we are passing this compare function as a parameter. It is going to call this parameter with a pair of numbers, and these pair of numbers get compared, and accordingly the sorting happens. Okay, so if you want to see what numbers are being compared by this, so maybe you can see you can see out comparing a and b. Okay, now we are not making a call to this function, so there are multiple calls that are being made to this compare function, but they are made by the sort function. They are not made by us, and the code of sort function is hidden in the library, which is present in the hash include algorithm file. Okay, so if I now show you this code again, inbuilt sort, you will see it made a lot of comparisons. Okay, it made a lot of comparisons before coming up with a final output. So these all comparisons were happening in the background. Now they are visible because we put a cout statement here. Okay, so I wanted to tell you this function is not getting called here, it is being passed, and inside that sort function it is being called multiple times. Okay, multiple times, and it controls the comparison or the direction in which the sorting should proceed. Okay, whether the larger element should come to the front or the smaller element should come to the front. So that's all for this lecture. I hope you really understood this one. So there are two options. You can either use sorting and then a reverse method, or you can use a comparator. And there is one more option. I can just quickly tell you. So there is an inbuilt comparator as well. Okay, so if I do the sorting, it will do it in ascending order, but if I pass in, I think the greater, I don't remember the syntax exactly, it should be greater int like this. Okay, and if I now run the code, sorry, we should run this file sort greater dot slash sort greater, and you can see we are getting in the reverse order. We are getting the elements in the reverse order. So this is another option. So this is a kind of a inbuilt, this gives you an inbuilt comparator object or inbuilt comparator function that is being used to sort these particular elements. Okay, so this is third option. So we learned about three things. We learned about the sort function, we learned about comparators, we also learned about the reverse function, and we'll also learned about the greater function. Okay, so that's it. That's how we can solve our problem of sorting. You can pick any way which you like, and that's all for this lecture.